Okay, we want to talk about logarithmic equations. And whenever we work with logarithms, it's very important to remember the definition of a logarithm. Y is the logarithm with the base a of x if and only if a to the y equals x. So what this means is that a logarithm is just another way of saying exponent. If y is a logarithm with the base a of x, it means that y is the exponent that we can raise a to and get x. Alright. So there are three different ways that a logarithmic equation could be set up. We could have x in the base, as we do here. So the logarithm base x of 64 to the over 27 equals 3. Or we could be taking the logarithm to a certain base of x. As we do here, we've got the log base 9 of x is 3 over 2. Lastly, we have the log base 64 of the cube root of 8 is x. So x is on its own over here on the other side of the equation. Now we can solve all three of these. They're going to be a little bit different because x is in a different place for each one, but they're all going to involve rewriting the equation based on this definition here. So let's try the first one here. We've got log base x of 64 over 27 is 3. Now, remembering our definition of logarithms, we know that x is the base here. The logarithm is 3, so the exponent is 3. Logarithm is just another way of saying exponent. X to the third is 64 over 27. It's the log base x of 64 over 27, which means the log base x that will give me 64 over 27. And rewriting logarithms like this just takes a little bit of practice, but once you've done it, you're halfway there. Alright, now all we need to do is take the cube root of both sides. So we get cube root of x to the third is the cube root of 64 over 27. This, of course, is just going to be x. And then we have the cube root of 64 over the cube root of 27. And we know the cube root of 64 is 4. And the cube root of 27 is 3, so x equals 4 over 3, and we're done with that one. So it's really pretty easy once we've learned how to rewrite it. Let's do the same thing with this. Remembering our definition, log base 9, so 9 is our base. The log base 9 is 3 over 2, so the exponent is the logarithm. The exponent is 3 over 2. And x, it's log base 9 that will give us x. So when you raise 9 to the 3 over 2, you get x. Alright, 9 to the 3 over 2. Well, we can calculate that pretty easily. We just have to rewrite it this way. 9 to the 1/2 cubed, and we're doing that with our properties of exponents. Remember that anything, well, let me write the property here. A, x to the a to the b equals x to the ab. Now in this case, we have 1/2 as our a and 3 as our b. So 1/2 x to the 1/2 to the third is the same as x to the 3/2, or 9 in this case. Alright, so we've got 9 to the 1/2 to the cube, or to the third power, is x. And of course we know that 9 to the 1/2 means the square root of 9, which is 3. So we just have 3 cubed equals x, or 27 equals x. So that's how we solve that equation. Again, not too hard once we know how to rewrite it. Let's look at the third equation here now. This one may be the hardest because it looks like it would be the easiest because x is already isolated for us. But the thing is, we have to figure out what the log base 64 of the cube root of 8 is, and to do that we're going to have to rewrite it as an exponential equation like this. 64 to the x equals the cube root of 8. So 64 to what power is the cube root of 8? Well, in order to do this, we're going to have to do a little bit of rewriting. Let's start out by rewriting 64 as 8 squared. So we've got 8 squared to the x equals, and then here we'll rewrite this as an exponent instead of a radical. So the cube root of 8, you remember, is the same as 8 to the 1/3. Alright? So we've got 8 squared to the x equals 8 to the 1/3. And again, we're going to use this same law of exponents that says x to the a to the b equals x to the ab. In this case, our a is 2 and our b is x. So we can take x squared, or 8 squared to the x, and rewrite that as 8 to the 2x. So now we have 8 to the 2x equals 8 to the 1/3. And since the exponential function is a one-to-one function, this can only be true if 2x equals 1/3. Now we have 2x equals 1/3. We can just divide both sides by 2 real quick, and we get x equals 1/6. And there we go. We've solved all three of these equations. All of them were logarithmic equations. They had the x in different places, and we were able to solve them all just by rewriting the equation according to this rule.